Hello everyone, welcome to Applied Chemistry Tutorials. Today we are going to talk about problems related to binomial theorem. So in our previous lecture we have discussed about binomial theorem, its significance and the derivation. So if you are interested about that, please go and check this link here. And as a quick recap, binomial theorem for any positive integer n can be given as a plus b whole to the power n equals to nc0 multiplied by a to the power n plus nc1 multiplied by a to the power n minus 1 multiplied by b plus nc2 multiplied by a to the power n minus 2 multiplied by b square plus dot dot plus ncn minus 2 multiplied by a square multiplied by b to the power n minus 2 plus ncn minus 1 multiplied by a multiplied by b to the power n minus 1 plus ncn multiplied by b to the power n. So we are going to use this formula in several problems as discussed in this video. So let's start with example problem 1. Expand 1 plus x whole to the power n. So we are rewriting the problem statement here, 1 plus x whole to the power n, and we can obtain the formula of a plus b whole to the power n from binomial theorem and mention here. So if we consider a equals to 1 and b equals to x, then we can expand 1 plus x whole to the power n as nc0 multiplied by 1 to the power n plus nc1 multiplied by 1 to the power n minus 1 multiplied by x plus nc2 multiplied by 1 to the power n minus 2 multiplied by x square plus dot dot plus ncn minus 2 multiplied by 1 square multiplied by x to the power n minus 2 plus ncn minus 1 multiplied by 1 multiplied by x to the power n minus 1 plus ncn multiplied by x to the power n. So we can clearly see that here 1 to the power n equals to 1 to the power n minus 1 equals to 1 to the power n minus 2 equals to 1. Also here 1 square equals to 1. So we can simplify this as nc0 plus nc1 multiplied by x plus nc2 multiplied by x square plus dot dot plus ncn minus 2 multiplied by x to the power n minus 2 plus ncn minus 1 multiplied by x to the power n minus 1 plus ncn multiplied by x to the power n. And we can further rewrite this statement if we calculate the values of nc0, nc1, etc. So if we use the formula of combination, we can easily find that nc0 equals to 1, nc1 equals to n, and so on. And both the formats are acceptable. So as we can see that this is the expanded form of 1 plus x whole to the power n. Now going into example problem 2, compute 999 whole to the power 5. So we are rewriting the problem statement 999 whole to the power 5 which equals to 1000 minus 1 whole to the power 5. And we can further rewrite it as 1000 plus minus 1 whole to the power 5. Now we already discussed about the binomial theorem which gives the expansion of a plus b whole to the power n. Now here we can assume that a equals to 1000 and b equals to minus 1 and n equals to 5. So we can expand this as 5c0 multiplied by 1000 to the power 5 plus 5c1 multiplied by 1000 to the power 5 minus 1 multiplied by minus 1 to the power 1 plus 5c2 multiplied by 1000 to the power 5 minus 2 multiplied by minus 1 whole square plus 5c3 multiplied by 1000 to the power 5 minus 3 multiplied by minus 1 whole cube plus 5c4 multiplied by 1000 to the power 5 minus 4 multiplied by minus 1 whole to the power 4 plus 5c5 multiplied by minus 1 whole to the power 5. Now we can easily calculate the values of 5c0, 5c1, 5c2, 5c3, 5c4 and 5c5 using the formula of combination. So 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is 10, 5c4 is 5 and 5c5 is 1. So we can rewrite it as 1 multiplied by 10 to the power 15 minus 5 multiplied by 10 to the power 12 plus 10 multiplied by 10 to the power 9 minus 10 multiplied by 10 to the power 6 plus 5 multiplied by 10 cube minus 1. And for ease of calculation we are rewriting this step in a different format here, and after addition and subtraction we can have it as 995009990004999. So this is the value of 999 whole to the power 5. So now we are moving into example problem 3. Show that 9 to the power n plus 1 minus 8n minus 9 is divisible by 64 where n is a positive integer. So we are rewriting the problem statement again. So 9 to the power n plus 1 minus 8n minus 9, and we can rewrite it as 8 plus 1 whole to the power n plus 1 minus 8n minus 9. Now we know the binomial theorem and how to expand a plus b whole to the power n. So here consider a equals to 8 and b equals to 1, and also instead of n the power is n plus 1, so we can expand 8 plus 1 whole to the power n plus 1 as n plus 1 c0 multiplied by 8 to the power n plus 1 plus n plus 1 c1 8 to the power n multiplied by 1 plus n plus 1 c2 multiplied by 8 to the power n minus 1 multiplied by 1 square plus plus n plus 1 c n minus 1 multiplied by 8 square multiplied by 1 to the power n minus 1 plus n plus 1 c n multiplied by 8 multiplied by 1 to the power n plus n plus 1 c n plus 1 multiplied by 1 to the power n plus 1, and we'll keep minus 8n and minus 9 outside of the bracket as it is. So one thing to notice here we can see the terms 1 square, 1 to the power n minus 1, 1 to the power n, 1 to the power n plus 1. These are all equal to 1. Again, we know that the formula of combination gives us NCR equals to factorial n divided by factorial r multiplied by factorial n minus r. So from this we can have n plus 1 cn equals to n plus 1 and n plus 1 cn plus 1 equals to 1. So we will keep these two terms outside of the second bracket in our next step. So we can have n plus 1 c0 multiplied by 8 to the power n plus 1 plus n plus 1 c1 multiplied by 8 to the power n multiplied by 1 plus n plus 1 c2 multiplied by 8 to the power n minus 1 multiplied by 1 square plus so on and so forth plus n plus 1 c n minus 1 multiplied by 8 square multiplied by 1 to the power n minus 1, and these are all in the second bracket. So the penultimate term which was in the second bracket we can simplify it as plus 8 multiplied by n plus 1, and the ultimate term which was inside the second bracket we can simplify it as plus 1, and we already had minus 8n and minus 9 outside of the bracket. So the purpose of doing all this is we can cancel out each of this term outside of the bracket and it will turn into 0. For simplifying this, we can have it as n plus 1 c0 multiplied by 8 to the power n plus 1 plus n plus 1 c1 multiplied by 8 to the power n multiplied by 1 plus n plus 1 c2 multiplied by 8 to the power n minus 1 multiplied by 1 square plus plus n plus 1 c n minus 1 multiplied by 8 square multiplied by 1 to the power n minus 1. So we can clearly see that here 1 square equals to 1, 1 to the power n minus 1 equals to 1, and that is applicable for any other terms in between these two terms here. We can also notice that all these terms are divisible by 8 square or 64. So if we take out 8 square or 64 as the common term, we can have 64 multiplied by, in the second bracket, n plus 1 c0 multiplied by 8 to the power n minus 1. So as we are taking out 8 square, so this 8 to the power n plus 1 will become 8 to the power n minus 1, and similarly we will have plus n plus 1 c1 8 to the power n minus 2 plus n plus 1 c2 8 to the power n minus 3 plus plus n plus 1 c n minus 1. Now we can clearly see that these terms are divisible by 64 and hence it is proved. Now let's move on to example problem 4. Find x plus y whole to the power 4 minus x minus y whole to the power 4. Hence evaluate 2 plus root 3 whole to the power 4 minus 2 minus root 3 whole to the power 4. So let us start with x plus y whole to the power 4. So coming back to the binomial theorem formula, a plus b whole to the power n, and if we consider a equals to x, b equals to y, and n equals to 4, so we can expand x plus y whole to the power 4 as 4c0 x to the power 4 plus 4c1 x cube y plus 4c2 x square y square plus 4c3 x y cube plus 4c4 y to the power 4. And in a similar way, we can also expand x minus y whole to the power 4. So we can rewrite x minus y whole to the power 4 as x plus minus y whole to the power 4. And here we can clearly see that if we consider a equals to x and b equals to minus y and n equals to 4, we can expand it using the binomial theorem, and it will be equals to 4c0 x to the power 4 plus 4c1 x cube multiplied by minus y plus 4c2 x square multiplied by minus y whole square plus 4c3 multiplied by x multiplied by minus y whole cube plus 4c4 multiplied by minus y whole to the power 4. And we can simplify it as 4c0 x to the power 4 minus 4c1 x cube y plus 4c2 x square y square minus 4c3 xy cube plus 4c4 y to the power 4. So now we can go back to the problem statement, that is x plus y whole to the power 4 minus x minus y whole to the power 4, and after using the binomial theorem we can rewrite it as x plus y whole to the power 4 will become 4c0 x to the power 4 plus 4c1 x cube y plus 4c2 x square y square plus 4c3 xy cube plus 4c4 y to the power 4. And similarly we can rewrite x minus y whole to the power 4 here, so it will become minus in the bracket 4c0 x to the power 4 minus 4c1 x cube y plus 4c2 x square y square minus 4c3 xy cube plus 4c4 y to the power 4. And we can clearly see that this is plus 4c0 x to the power 4 and this one is minus 4c0 x to the power 4 if we take this out of the bracket. So these two terms will cancel each other, and again this is 4c1 x cube y and this is minus minus plus, so this will again 4c1 x cube y, so these two terms will not cancel each other. Again 4c2 x square y square and this is minus 4c2 x square y square, so these two terms will cancel each other. This is 4c3 xy cube and this is minus minus plus 4c3 xy cube, so this will not cancel each other. And finally we have 4c4 y to the power 4 and this is minus 4c4 y to the power 4, so this will cancel each other. So we can finally simplify it as 2 multiplied by 4c1 x cube y plus 2 multiplied by 4c3 xy cube, and we can rewrite it as 8 x cube y plus 8 xy cube. Because we know that 4c1 equals to 4c3 equals to 4. And finally if we want to take 8xy as the common factor, we can have it as 8xy multiplied by x square plus y square. So this is the value we obtained after simplifying x plus y whole to the power 4 minus x minus y whole to the power 4 using binomial theorem. Now we have already shown this in the part 1 of this problem. Now move on to the second part. So we need to evaluate 2 plus root 3 whole to the power 4 minus 2 minus root 3 whole to the power 4, which is similar to that expression here. And if we put x equals to 2 and y equals to root 3, we can easily get the value of this. So plugging in the values, x equals to 2 and y equals to root 3, we can obtain 2 plus root 3 whole to the power 4 minus 2 minus root 3 whole to the power 4 equals to 8 multiplied by 2 multiplied by root 3 multiplied by 2 whole square plus root 3 whole square. So after simplification we can have it as 8 multiplied by 2 16, root 3 multiplied by 2 whole square is 4 and root 3 whole square is 3, so 4 plus 3 here, and we know that 4 plus 3 is 7, so 16 multiplied by 7 is 112. So we can have it as 112 root 3. So this is the value we obtained after simplification of 2 plus root 3 whole to the power 4 minus 2 minus root 3 whole to the power 4. And that's all for today. And if you like this video, please comment and share, and please subscribe to our channel, and thanks for watching.